Good morning, everyone. Can everyone hear me? Okay, thank you. Okay, sorry, I could not make it. I'm really having lower back pain and also my shoulder blade, so I cannot drive and I cannot sit for long. I need to rush to the treatment after the class. So sorry, cannot make it. Hope to see you guys tomorrow. Okay, so we have discussed tutorial 5, the code related question, the one we need to transfer into the control flow graph and then to calculate the cyclomatic complexity and also to identify the basis path. So all the question I have discussed. So we left with the theory question 1 until question 7. Okay, so we settled that first. Then once we're done, then I will start to discuss chapter 6. Okay, let me share my screen. Okay, can see my screen. So tutorial 5, we have done all the question 8, 9 and 10 in the class. So I want to discuss the first 7 question, which is more onto the theory thing. Okay, so question 1, explain what control flow graph is. Okay, so we have been drawing the control flow graph according to the given source code. So what is this control flow graph? What you understand about this control flow graph? What you understand? So let me open the slide. Hold on now. Okay, so this is chapter 5, what we have discussed. So if you see, control flow graph is actually a graphical representation of a program's control or the logical structure of the program. So what we are trying to do by drawing this control flow graph is we try to understand how is the program's control or how is the control flow of the source code of the program. It means from where to where it is flowing. So based on the line by line, we are actually translate the control flow or the logical structure into the control flow graph. Okay, so control flow graph is a graphical representation. The source code we translate into the graphical mode. Okay, so that's what is meant by control flow graph, the graphical representation of a program's control or the logical structure. Okay, then the next question is list and describe the three primitive of control flow graph. So the three primitive is what we have been checking when we are drawing the control flow graph, which is the decision. Okay, and then we have the junction, and then we have the process block. Okay, so decision is means when the node is having multiple edges coming out. For example, when there is a decision making, so for example if statement, switch statement, and then our loop. So whenever there is multiple edges, that is what we call the decision. Then we have a junction. Junction is where the multiple edges merge back to one node. So it means when we want to end the decision making, so end of the if, end of the loop, or end of the switch statement, whatever we are bringing back to the main node. And then the third one is the process block. So process block is actually when the statement is actually not having any decision or not having any junction, but it is actually a straight line of a code. So for example, when we have a declaration, initialization, for printing, for any calculation, so all this is a process block. So it will be one edge coming in, one edge coming out. Okay, so this will be the three primitive which you need to take care when you are drawing the control flow graph. Okay, the next question, explain the following, which is the statement coverage, the branch coverage, and then the path coverage. Okay, so statement coverage, as what I have mentioned, it's only covering the true path. It means when we have a program and when it's having a decision. So let's assume if there is no decision making happen, then it means it will cover all the line or all the node as usual. Okay, that's why statement coverage is also known as a node coverage. Let's assume if there is a decision making, for example, there is a condition to check, and if the condition is true, what is the action, and if the condition is false, what is the action. So when we set statement coverage, it means it will only cover the true path of the program. So it means there is no false or there is no invalid of data happen which we need to test. So we only follow the correct flow of the statement. See, we only want to see how the program work well without any errors. Okay, so it will only cover the true path. But when we said branch coverage, which is also known as edge coverage, it will cover all the edges. It means the possible of edges. It means it will cover the true, it will cover the false path also. So it means when the condition is true, then how the program is working fine without any issue. And we need to also test the false path where to see if there is any unexpected invalid data or any invalid action, what happened. So we need to cover both of it. So for us to achieve the 100% coverage, statement coverage, we just need to cover the true path. Then we already achieved the 100%. But if our aim is we want to cover branch coverage, it means we need to cover the true and also the false. Then only we can cover the 100%. If we only tested the true without covering the false part, it means we cannot achieve the 100%. So we need to cover both of the branches. Okay, then the third one is the path coverage. So path coverage is what we do where we actually have every single basis path which actually can be executed. So this can be with loop, without loop. Okay, where we need to identify all the path. So it means it might be similar with the branch coverage, where when we try to cover each of the branch, automatically we try to cover each of the path. But sometimes path coverage we will have more than the branch coverage because there is repetition of certain path happen, especially when we have a loop. So we actually need to do the repetition of entering the loop, and there is multiple path can be the choice every time it enter the loop. So in that case, our path coverage will have more path to test compared to branch coverage. So in conclusion, statement coverage, branch coverage. Statement coverage can be having less path than branch, or they are both same. Okay, but they can never be more. Okay, and branch coverage and path coverage, the same thing. Branch coverage can have the same numbers with the path coverage, but sometimes it can be less path to cover. Okay, so we focus more on the path coverage because this is where we able to test every single possible path. So it means the coverage of our testing will be more compared to statement and branch. So that's why my focus is more onto the path coverage, where you will draw the control flow graph, and then you calculate the cyclomatic complexity, and then you identify the basis path. So this is under the path coverage. Okay, then the next question is, what is cyclomatic complexity? So under the path coverage, we have this one called cyclomatic complexity, where you need to do the calculation. Okay. Okay, so this one, cyclomatic complexity. So cyclomatic complexity is a software matrix that provides a quantitative measure of logical complexity of a program. So when we want to know the complexity level of the code given, we will use this cyclomatic complexity as the software matrix. So you should know matrix means a standard which we use for measurement, and when we are dealing with quantitative data. So the same thing goes here. For us to calculate or to measure the complexity level of a program, we will use this cyclomatic complexity as the software matrix. So from the calculation, so if you see, this is the formula which we use to calculate, where the number of edges minus the number of node and then plus 2. Okay, so this value which we get from this measurement is actually giving us the number of the independent path. So the more bigger number we are getting, it means the more path or more basis path or more independent path which we need to test. So when the number is bigger, more path we need to test, automatically the complexity of the program is also more. And same thing, if the number is lower, then it's indicated that the program's complexity is lower or is less. So that's why we have less path to test. Okay, the reason why we need to identify the path here, because from here is where we will prepare our test cases for us to conduct the testing. Okay, so this will be the cyclomatic complexity. Then the next one is explain the 3 steps to identify and to define the test cases. So this is actually what we have been doing, okay, where the first one is we draw the control flow graph. It means after we get the source code, from the source code, we will translate it into the control flow graph. So it means we need to draw the control flow graph. And then from the control flow graph, we identify the number of edges and the number of nodes, and we will determine the cyclomatic complexity by using the formula. And from there, when we get the number, we will actually determine the basis path or the independent path. So based on the path we get, we will prepare the test cases. So it means every single path which we identify, we need to prepare the individual test cases for us to execute the code. So this is how we conduct the white box testing. So as a programmer, while we are developing the code, we will be conducting the white box testing. So white box testing is not something we will do after we complete, because our source code, we cannot translate thousands line of source code into a control flow graph. It's not going to make sense. So that's why we have to take a little code, for example, maybe a function, or maybe one or two function combination of it, for us to translate into the source code, because this is 100% manual method. So we cannot translate thousands line of source code into a control flow graph. So that's why programmer will conduct the white box testing while they are actually developing the program. Okay, so that is about the test case part. So describe the four kinds of loop test. So this one I have go through the four types of the loop test which we can conduct, which is the simple, okay, simple loop, okay, where we have the pre-condition or the post-condition, where we check the condition and then do the action, or we do the action once and then we check the condition to proceed with the loop or not. And then we have nested loop. So nested loop, normally we have the inner and the outer loop, where we check the condition and then we will when the outer loop is true, then it will enter into the inner loop and it will do the looping until the inner loop will be false, then it will be out back. So they are actually depend on each other's input output. Then we have the third one, which is concatenated. So concatenated, we have two different types of concatenated. One is dependent concatenated and one is independent concatenated. So when we say independent, it means they are just two different simple loops. So they are not depend on each other for any reason. Okay, and if we say that it's a dependent concatenated, it means they are similar like a nested loop, where they depend on one one loop's output or input for us to determine the looping. Okay, then the last one is actually unstructured loop. So unstructured loop means something which we cannot do the test, because we don't know how it is being designed, because it is something unstructured. So we must make sure that we do the redesigning to make it either it's a simple loop, nested loop, or dependent or independent concatenated. Then only we can do the testing. So this will be the four different kind of loop tests. Okay, then the next one is, what are the challenges in white box testing? Using your own word, list and explain four challenges in white box testing. So we have discussed black box testing. It means we have discussed under the dynamic black box testing in chapter 4. So chapter 5, now we have been discussing the white box testing. So what can be the challenges in white box testing compared to black box testing? What can be the challenges based on your understanding or your logical? What can be the challenges of white box testing? Any idea? What can be the challenges in white box testing compared to black box testing? No challenges, is it? Okay, find out yourself. Huh? So, what can be the challenges in white box testing compared to black box testing? Okay, so that's it for the tutorial 5. So, the other questions I already discussed. Okay, so let me start with chapter 6 because it's kind of long a bit. At least I can start so that we can finish it tomorrow. Okay, so tomorrow I'm planning of conducting the lecture first in the morning because we might not have enough time to go through the assignment progress in that 2 hours because we have 5 different groups. So we will do the continuation of lecture in the morning when we meet. Then in the evening we will do the assignment progress checking. Okay. Okay, so chapter 6 is about the software testing life cycle. Okay, so we have been discussed about SDLC throughout your software engineering courses. You always discuss about SDLC, software development life cycle. Okay, and this is software testing life cycle. So for us to do the testing, we also have its own life cycle which we need to identify the phases and to do the work according to that phases. Okay, so under the software testing life cycle, we have these 6 different phases involved, where the first one is the requirement analysis. Okay, where we are going to discuss about the requirement and then the quality attributes of the requirement which is needed to be done for the testing purpose. Please do not get confused. Requirement analysis here is not about the development part. So let's assume in our software development life cycle, we always start with the requirement analysis. So once the requirement has been gathered, it's going to be documented, it's going to be analyzed. So after the requirement analysis being done, it's actually going to be after the requirement has been gathered, has been documented, it's actually going to be distributed to the development team and also to the testing team. Okay, so here the testing team is not going to wait until the development will be finished. So while the development team will be working on the requirement for them to do the design, for them to do the development of the code, the testing team actually will analyze the requirement for them to prepare for the testing. Okay, so the requirement analysis under the STLC is more to the testing activity, nothing about the development. Okay, so after the requirement analysis, we will have the test planning. Okay, please do not get confused. Test planning here means the activity, planning activity. Test plan means is the documentation you are working on. As how you are planning, you need to document it, what you are planning. So that is what we call the test plan, the document. Okay, then after that we have the test case development. According to the requirement, according to the test planning, then we will do the test case development. Okay, and then environment setup or the test environment setup. So I have been discussing about this test environment again and again, where it's a setup of environment for testing purpose, where the environment should be similar to the operational environment in the future. Okay, so for that environment set up, okay, what are the software we need, hardware we need, and then if data network, any additional tools, devices, so we need to do the test environment setup. Okay, then after that, the fifth phase is test execution. So we have done with the planning, we have the test case, and then we already have the environment. So we will do the test execution. So it means every single test cases need to be executed for us to know the result. Then the last one will be test cycle closure. So it means once we have completed with the test execution, we need to do the closure of that particular test cycle. So test cycle is something like a round of testing which we do start from our first test case until the last test case we need to execute. So once we complete this, we call as a cycle, test cycle. So normally we need to do the closure of that particular test execution or the test cycle. So this will be the six phases under the SPLC. So our chapter 6, 7, 8, and 9, we will be discussing about this SPLC. Okay, so we will discuss one by one the phases and what will be involved, the documentations, and so on. Okay, so before we will discuss about the STLC, what is this independent test? Okay, so if you see in our chapter 1, we have seen the independence level or the testing level, okay, which is better to be conducted. So normally for a programmer to test their own code, it is good, but it is not efficient enough because programmer might not able to identify their own mistakes. Okay, or the developers know the right way or the right flow of the software according to their understanding of the